There is another approach which is known as the duration convexity approach. Okay, in this approach what we do is we compute the duration of each of the bond, or to make it more simple we compute the duration of the portfolio. Okay, similarly we compute the convexity of the bond and convexity of the portfolio, right? This would be one measure, right? So let's say duration is 5, convexity is 50. Using these two values, okay, we can say that the change in the yield is 0.5%. Okay, it is decreasing, so we can compute the new price of the bond. The percentage change in the price is given as minus duration into del y. So you know what is the percentage change in the price of the bond, and from there you can compute the new price, right? So it is much simpler. Okay, however please note that this gives you incorrect result. Accuracy is not 100%, but the incorrectness, it does not mean that the accuracy is much lower. Okay, it is highly accurate when the change in the yield is low. Okay, for let's say up to 10 basis point, okay, of change in the yield, you can say that duration will give you approximately correct value. So if you see the error is low, okay, when change in the yield is low, but the error is high when the change in the yield is high. But if you use convexity, okay, along with the duration, okay, the error becomes much lower. However, there is one more problem with this duration. Okay, this duration approach, it assumes that the change in the yield curve is parallel. So if this is your yield curve, it assumes that there is a parallel shift. Okay, so it assumes parallel shift. For if the yield curve is not shifting parallelly, okay, then duration approach will lead to wrong values. So the advantage is less calculation, and disadvantage that you have is, okay, it only works for parallel shift, okay, and only works when the change in the yield is low, and it gives you less accurate values.